Okay, so we're looking at equations of lines. So the next exercise, I think it's actually called equations of lines. So it's exercise C. So it introduces a number of types of lines. So the first one, and we're always looking at the equation of a straight line, a linear function. So we've already looked at y equals mx plus c, and this one is called the gradient intercept line. It's in that form. So this y equals mx plus c is in gradient intercept form. Then we have the general form, and if you remember, we did have a look at this in class. Okay, so this is the general form, where we said that a must be greater than 0. So whenever you write it in general form, a must be a positive number. And then we have vertical lines in the form of a equals x. So this is a vertical line. And of course, you know that this is my y, this is my x. So this line here, let's say that's 2, that's x equals 2. And what's next then? Y equals b is the horizontal form. Okay, and that means that the line, of course, is parallel to the x-axis. So if I draw a line down here and it cuts the y-axis at -5, then the equation of this line is y equals -5. Okay, now all of those are going to be used next, but there's one other form that is really, really important, and you will use it throughout the HSC, right? Something that we call the point gradient form. I can't emphasize how important this formula is. I can't emphasize enough, I should say, how important this formula is. So the point gradient form is y minus y1 equals gradient x minus x1. Okay? We're going to use it over and over and over again. Okay, so what do we need to use this? Well, we need the gradient. Okay, and we need a point. So here is my x1, my y1. So this is the point that I need in the question, or somehow I need to figure it out. So I need a point and a gradient. And of course, these don't change, okay? Because it's got to be in the form of either a gradient form, a general form, or either of these, depending on what the question says. All right. So, for example, a quick question looking at how to apply this formula. Find the equation of a line passing through the point, I don't know, let's say 3, 2, and a passing through the point 3, 2 with a gradient of -4. Okay, just making it up as we go. All right, let's have a look and see. How do I apply this? So I'm just going to go over here and show you the solution. Okay, so solution. Do I have a point? Yes. Do I have a gradient? Yes. I've got all the information I need. So using the formula. All right, let's sub everything in. All right, that y remains. So I have the gradient is -4, and the point we said was 3, 2. So this is my x1, y1. All right, so let's substitute y minus y1 is equal to my gradient, which is -4, and x minus my x1, which is 3. So I end up with y minus 2, expand the brackets, -4x plus 12. Add 2 to both sides. So y is equal to -4x plus 14. Okay, and what form is that in? The gradient intercept form. What if the question had said write it in general form? Easy, right? Remember the coefficient of the x must be positive, so I need to take that to the other side. So in general form, this will be 4x plus y minus 14 equals 0. Okay, and there it is in general form, and that's in gradient intercept form. Really, that's what you need to be able to do. All right, there are some warm-up questions that you need to do. I might just do one of those here so that you can have a look, and then the rest you can try it yourselves. Okay. All right, warm up. Number 1 I'm going to do, which says find the equation of the line that passes through the point. So the points are A is 2, 5 and B is 6, 13. I want to find the equation of that line which passes through those 2 points. And I want the answer in general form or in point gradient form. If I quickly sketch this on the side, just to give you an idea of what this looks like. So 2, 5 is somewhere over here. This is point A. And 6, 13, somewhere here, that's point B. So what am I doing? I'm finding the equation of this line here. Okay, let's do that. Well, do I have the gradient? No. Can I figure out the gradient? Yes. I can use m equals y2 minus y1 over x2 minus x1. This is my x1, y1, x2, y2. Let's find the gradient there. 13 take away 5 all over 6 take away 2. Okay, so 13 take away 5 is 8. 6 take away 2 is 4, so the gradient is 2. Okay, so that's the gradient. Now, what's the next formula that we need to use? Point gradient formula. All right, because now I have a gradient and a point. I actually have 2 points. I can choose either one of them. I'm going to stick with A. Okay, so y minus y1 is equal to m bracket x minus x1. Let's go. Y minus 5 is equal to my gradient, which is 2x minus 2. Expand the brackets. Add 5 to both sides. Y is equal to 2x plus 1. And there is my gradient intercept form. Okay, but now if I wanted to change that into the general form, well, here, let's do this over here. Into the general form, the coefficient of x must be greater than 0, so it must be positive. It already is, so I need to bring the y to this side. So that becomes 2x minus y plus 1 equals 0. And here is my general form. Okay, good luck with the rest of the questions.